Equations and inequalities. This session presents mathematical operators and how we use them. And we just take an overview of the many that are on your program and how we get used to seeing them. I'm going to start with the following pairs of mathematical operators. Mathematics is a number of linked or paired operations whereby the effect of one has the opposite effect of its twin. Pairs of related operators include plus and minus, addition, subtraction, multiplication, division, squares and square roots, cubes and cubic roots, powers and logs, and trigonometric, inverse trigonometric functions. There are others in there as well. You may have remembered the complex conjugate, the twin complex number that floats around with it, locked, sharing certain characteristics together. There's a whole lot of things that go around, the yin and the yang, that sort of match and follow each other around in maths. We're going to start with two you would have some familiarity with, addition and subtraction. So let's just take x plus 2 is 5. X plus 2 is 5. What's x? 3. You're doing that instinctively, and I'm going to ask you to sort of reflect on not doing that instinctively. And saying, okay, x plus 2 is 5, what's x? X plus 2 is 5. I'm going to leave a space here, and I'm going to say, what's the twin of addition? Subtraction. So if I were to take the twin of addition and say minus 2, 2 and minus 2, I'd say 5 and minus 2 on this side as well. Because whatever I do on one side, I do on the other side as well. Now 2 minus 2, what happens there? So I get x equals 5 minus 2 is 3. So I find that x is equal to 3. Now, you've been doing that in micro steps, but you've for long since forgotten the micro steps, and you just do it instinctively in your head. Is that okay? Let's see if it works for subtraction. Y minus 3 is 8. Now, if somebody said to you, y minus 3 is 8, you'd tell me what y is, wouldn't you? What's y? 11. But again, if we said y minus 3 equals 8 over here, and we said, what's the twin of minus? Plus. 3 and minus 3, they cancel. 8 and 3, 11. Is that okay? So it's a slow way, it's a more granular way than what you're doing in your head, okay? You're just undoing an operation of plus or of minus. And that's addition and subtraction. Now let's take the next two, multiplication and division. Somebody says to you that 3x is 12. I went in and I bought 3 bars of chocolate and they cost me 6 quid, or they cost me whatever, 3 quid. What did each one cost me? So multiplication, 3x is 12. What's x? 4. Again, straight off the top, it's sort of, there's no gap there. But we could say that 3 is a multiplication. So it's 3 times x. So we say 3 times x is 12. And what does that 3 outside a bracket mean? It's multiplication, isn't it? And what's the opposite of multiplication or its twin? Division. So if I were to divide this by 3 and this by 3, the two 3's would cancel. And I'd get x is 12 over 3, and 12 over 3 is 4, which is the answer you would have got, okay? But we're just breaking it up into that particular step. Is that okay? Now, there we have 3x, x is 4. Division. Y over 5 is 10. Y over 5 is 10. What do you think y is? A fifth of y is 10. A fifth of what I own is a tenner. How much do I own? 50. So again, you'd say y over 5 is 10. And really what you're really saying is, on the left-hand side, conventional left-hand side, I just want the variable y on its own. I don't want any other mess. And this is in the way. This 5 is in the way. What is it? How is it in the way? It's in the way as what? As divider, isn't it? As division, isn't it? So what's the pair of division? multiplication. So if I were to multiply it, I'd have to multiply the other side as well. Because whenever I do on one side, I have to do on the other side. But what would the two 5s then do? I get y is equal to 50. Is that okay? So what we're doing is we're looking at an operation, and granularly we're saying, how do I get rid of that? Because it's in my way. I was asked for y, not y over 5. Is that okay? And that's division. Now we look at squares and square roots. We're moving up a little bit. We're into late primary or something like that. And we're saying x squared is 9. What's x? Off the top of your head, what would you say? 3. But another way of looking at that is, what's an x squared? What's the pair of squaring? Square root, isn't it? I don't like this x squared on this side. So the natural twin of that is the square root. So if I take the square root of this and the square root of that, what happens to the square root of a square? Effectively, what happens is it gets rid of the thing I didn't like. So I get, well, I should leave that as it is, because I'll do that so that that's correct. The x squared is 9. I find the thing, I rewrite it out. So I get x squared is 9. But I say the square root of this must be equal to the square root of this. And really the square root is a way of getting rid of this. So x is equal to the square root of 9. And what's the square root of 9? Usually 3. What else could it be? It could be minus 3, isn't it? Because minus by minus is 9, is plus as well. Is that okay? But again, we're seeing this sort of logical pattern of the thing we don't like. Now, so that's our squares and getting our x's plus or minus 3. Now our square root. Somebody says that the square root of x is 5. What's x? You're not answering back as quick as you were with addition and subtraction, okay? But you do know the answer. But the other way of looking at this is saying, well, what's the twin of what's the pair or the mirror image or the partner of the square root? Square. So if I don't like a square root, I say I'm going to get rid of it. So I'm going to square both sides. And if I square a square root, what happens? The only reason you do it is to get rid of it, isn't it? The only reason you took the minus 2 from the plus 2 was to get rid of it. The only reason you did the square of a square root is to get rid of it, isn't it? So this disappears, and you're left with x is equal to 5 squared. And what's 5 squared? 25. Is that okay? Now, cubes and cubic roots, okay? X cubed is 8. X cubed is 8. How do I get rid of the cube? Somewhere on your calculator, there's the inverse something, isn't it? These two are always locked as in partners. Is that okay? So the inverse of a cube is a cubic root. So if I write these out again, and I say the cubic root of 8, or the cubic root of this, must be the cubic root of this. Is that okay? And what's the cubic root of a cube? Well, I don't know, but it gets rid of it. That's all I need to know. Is the cubic root of 8. Is that okay? And after that, it's just putting this into the calculator. And the cubic root of 8 turns out to be 2. Is that okay? And we can do the calculator steps if that's an issue. But the main thing is, you don't actually care what a cubic root of a cube is. As far as you're concerned, it's just got rid of it. It's just x. That's what you were after. Is that okay? The next one is the cubic root of x is 3. The cubic root of x is 3. What's x? I don't know. But what's the opposite of the cubic root? What's the opposite of a cubic? What's its partner? Cube. So if I cube this, I can cube this. And if I cube it, what happens? The cubic root of x cubed means that all this stuff gets out of my way, and I just get x is 3 cubed. And 3 cubed is 3. cubed is 27. Is that okay? You see the patterns there? Okay, let's go on now to powers. X to the power of 10 is 1024. What's x? X to the 10 is 1004. How could I get rid of this x to the 10? That's the 10th power, isn't it? If you have a calculator button that says y to the x, or x to the y, or whatever it is, right? Is there an inverse of it? Or if there's not, there's probably one beside it that sort of says x to the root of y, or something like that. You probably have calculator buttons that say something like that, do you? Or that to the y, or y to the x, or, you know, y, x, y. Depends on how they show it. Is that okay? But they're close to each other, if not the inverse. Is that okay? If I have a 10th power, how do I get rid of a 10th power? 10th root. On the square, I square root it. On the cube, I cube root it. On the 10th, I 10th root it. Is that okay? So I'm going to get the 10th root of x to the power of 10. And that's going to be the same as the 10th root of 1024. What's the 10th root of x to the power of 10? I don't really care. It's x. Is that okay? X is the 10th root of 1024. Calculator 1024, probably something like this one, times 10, you'll find the answer is 2. Is that okay? Because 2 to the power of 10 is 1024. Is that all right? Do you see it's like a toolbox. It's like turning around from a straight head to a Phillips head or something like that. It's the absolute, it's the other one you need or whatever. Okay? It's the twin. Happy with that? The 5th root of x is 2. Here we've got the 5th root of x is 2. How do I get x? Do I like this 5th root stuff? No. What can I do? Multiply it to it. I could get the 5th root of x is 2, but if I were to take the 5th power of that, that'd be better, wouldn't it? Because all of this stuff then would just disappear and I'd be left with x. Is that okay? Happy with that? And it mightn't have been written like that. It could have been written like this. Instead of the 5th root, it could have said x to the power of 1 over 5 equals 2. What's x? And you'd say, well, I know that if I do this 5 times, x to the 5th, x to the 5th, x to the 5th will give me x to the power of 1 because you add those. And what's x to the 1? X. 2 to the 5 is whatever, 32 or whatever it is. Is that okay? For every single operation in maths, there's the flip. Is that okay? It just means that you can, when they put up any equation or any expression for you, you just flip and it goes away. Is that okay? Now here's the relationship in trigonometric functions. Sines and inverse sines, cosines and inverse cosines. And just look at what I'm saying here. I'm saying that if you have the inverse sine of theta, what's its twin? Sine. And if you take the sine of the inverse sine, it gets rid of it. Cos of the inverse cos gets rid of it. Tan of the inverse tan, it gets rid of it. Equally, inverse sine of the sine gets rid of it. Inverse cos of the cos gets rid of it. Inverse tan of the tan gets rid of it. I'm now going to do an example on that. Somebody says to you, the tan inverse of x is 45. Tan inverse of x is 45 degrees. What do they want you to find? Always on the left-hand side? X, isn't it? What's X? Do you like this? Generally not. Is that okay? It's a bit of a mess, isn't it? But what's the opposite of tan inverse? Tan. So I don't like this equation, but if I were to rewrite it and say, okay, tan is here, tan inverse x, we're told, is 45. Okay, leaving a bit of space. If I were to slip in tan here on this side and take the tan of this side, they'd still be the same, wouldn't they? Whatever I do on the left-hand side, I can do on the right-hand side. Isn't that right? Are tan and tan inverse partners? Are they opposites? X is equal to tan 45. Is 45 on your calculator? Is the tan button on your calculator? Have you got X? Is that okay? So all you do is you look at it and you say, I don't like this. I'd much prefer my life if that was just X, thanks very much. Whether it's just addition or multiplication or whatever, I'd much prefer if it was on the other side. Is that okay? Is that fair? Let's look at this one. Sine X is 0.5. What's X? Sine X, 0.5. What do I want on the left-hand side? X. What's the twin of sine? What's the sledgehammer that will give it a sine for me? Inverse sine. Is that okay? So if I was to take the inverse sine of sine x, the left-hand side, it would be the same as the inverse sine of the right-hand side. Okay? The inverse sine of the left-hand side versus sine means that they cancel. Why did they cancel? I chose them deliberately so they'd cancel. The only reason it got into the equation. X is now inverse sine 0.5. Is 0.5 in your calculator? Yeah. Press inverse sine, fine. X is 30. Okay? And these things just disappear. You've been doing them for years. You've been doing it so much in addition and subtraction that you've forgotten the steps involved. You just jump to the answer. So when you can't see the answer, you forget the steps. But all the steps have been there. Let's take this one then. The last two. I think the last two for the moment. Logs. There's two types. Sometimes the log is written log, and sometimes it's written log space base 10. This is log to the base 10. Okay? Just imagine that if we go back to the basics here, the opposite of logs, just so we know, I think they're there somewhere in the pattern. I can't maybe find them. But the twin of the sine is the inverse sine, and the twin of the log is 10 to the power. And the twin of natural log is e to the x. Okay? So let's just look at this log for the moment. Somebody says to you that log of x is 2. The log, log of x is 2. Even if that was a function you never heard of before, at this stage on your calculator, you could probably say, what's the inverse of it? How do you get rid of this log thing? Well, if you look at your calculator, you'll find that the inverse of the log is a thing called 10 to the power. So what I'm going to do is I'm going to rewrite this as log x is 2, but I'm going to put a 10 to the power in front. And 10 to the power of all of this is 10 to the power of 2. 10 to the power of log is 10 to the power of this. That's the twin. Now, what does 10 to the power of a log do? It just, I don't care. It just calls it x. X is 10 to the power of 2, which is 100. It just wipes it. Is that okay? So there's our x is 100. And the last one then, well, the last one in the logs, is 10 to the power of x is equal to 1,000. And they give you these questions a lot. and they give you a number, and you can't always spot it. You could spot that that's probably 10 cubed. But sometimes you don't spot it. You might say something like 25 to the power of x is 125. What's x? It's not 1, and it's not 2. Is it 1.5? How would I find it? I don't know. Very tricky. You can't do it off the top of your head. But you can do it this way. If somebody says 10 to the power of x is something, what's the twin of 10 to the power? Log. So log of 10 to the power of x is log of 1,000. What's log of 10 to the power of x? Wipes it out. X is equal to log 1,000. Now, 1,000, press the log button, x is 3. Okay? 10 to the power of 3 is 1,000. Get the idea? And you've been carrying around this set of tools all the time as the twin. And it unscrambles all of the equations for you into sort of stuff that you can move on then and do the interpretation later. The last one is natural log. These are basically not multiplying by 10 all the time by the magic number e, which is a cool number. Natural log of x is 3. So the natural log of x is 3. What's x? Well, what you do is you look up and you say, well, what's the twin of ln? What's its partner? What's its, mirror image? And you'll find that it's e to the power. This magic number around 2.7. So basically what they're saying is natural log x is 3. By the way, natural log can also be written as log to the base e if you've got a different calculator. Sometimes it's written like that with the base e rather than base 10. But it's generally called natural log of that. What's the thing that gets rid of it? E to the power. So this is e to the power, this is e to the power of that. You do all that, you get rid of that, x is e to the power of 3. So you stick in little e in your calculator, and you press power to the 3. So that's 2.71818 or whatever to the power of 3, or e1, and then power it. And that's it there. In this case, that was the log. Okay? And the final version of that one then is e to the power of x is 12. What's x? And you say, how do you get rid of an e? What's its twin? Natural log, natural log, natural log. They cancel. X is natural log 12. 12, function natural log. Answer. Is that okay? There's actually more than that. We could look at all of differentiation and say differentiation does one thing for you, and integration flips it back the other way. Okay? And there's a whole form of mathematics that deals with the opposite of differentiation. Because whatever you do in differentiation, you can do you can undo it. But for the moment, we're talking about this set of mathematical operators, plus, minus, multiplication, and all of those. And if you keep that as your tool set for this particular section, and say, that's in my toolbox now, and anytime I see anything ugly that I don't like, and they just want the variable on the left-hand side, I can find the undo for that. And that's that topic.